the official start. I don't think that's the end of the world.
No, again, because everybody knows that it's recorded and they can view it at their convenience.
And why don't we dig in out of respect for everyone who's already joined to stay on schedule.
Very good.
Okay, so I'll start. Welcome to the seminar presentation, Clean Tech Solutions, presented by IAQ Technologies, LLC, and the Energy Intelligence Center for Safe and Efficient Buildings. Next slide. This is a safe harbor statement because we are wholly owned subsidiaries of FOMO Corp. And it basically says that we're giving you the highest and best information that we know of, but there are often in life, opportunities to miss things. And I think this is a statement that has come out of, SEC practice, and we'll just go beyond it so that you understand that we're giving you everything that we know as of today to the best of our ability. Next slide. Jeff, why don't you go ahead and advance the next slide?
To 4.
Overview. Yeah, perfect. Here's the overview. FOMO Corp, which is our parent company, if you go back one. FOMO Corp is our parent company. It is a business incubation and acceleration business, parent to both IAQ Tech and EIC. And it's publicly traded on the OTC. The ticker is FOMC. Our focus is to improve indoor air quality and save energy. Here's how we do it. We provide comprehensive solutions designed to work with specific heating, cooling, ventilation, and lighting systems. For alignment, we align cost-effective and proven technologies to address air quality and energy efficiency. And turnkey, we can provide products, installation, utility rebate administration, and measurement and verification services. In addition to that, zero upfront cost options may be available. Those are typically subject to credit checks and the level of savings. We have on and off balance sheet options to share with our clients and our reselling partners. Next slide. We help navigate the complex nature of air quality and energy optimization. Lots of devices that are out there, in duct, on the wall, in the rooms, and in common areas, as well as the energy efficiency that can be at the air handler level and at the control level for the building management system. So this idea of navigating is a powerful word to help steer you through how to avoid some of that complexity, filter what is available and most relevant for your property. Next slide. Where do we begin? The equipment review is really foundational. So our work begins with reviewing your HVAC and lighting equipment for either new or existing projects. The data and the information review typically involves 12 months of utility bills. That sets the stage for us. And then the BMS, these building management systems, if there's availability, we prefer to have the read or the monitoring access to be able to really start to understand what's in the specific facility that we're addressing. The results are that these data points assist us for perspective to provide really the preliminary energy conservation measures, these ECMs, and the assessments and energy saving potential. It sets the stage. Next slide. We begin with the tailored optimization solutions and the 3 simple steps. The one is our process starts with a 1-page data sheet. So if we don't have access to that BMS, the kind of information on this sheet might include the number of chillers, the tonnage of each, the type of the BMS if that's relevant. Then the facility's existing MEP, mechanical, electrical, plumbing, the HVAC system. The step 2 is providing an assessment of the technical and the control opportunities. How can we help you? And step 3 is using step 2 with the assessment We align the most appropriate and cost-effective technologies for the ECMs considered. Basically, we need to know the type of existing HVAC equipment and the annual energy consumption to really help provide the guidance. And those 12 months of bills are very foundational. Next slide. The opportunities, we may be able to provide a pilot control and proof of concept monitoring to establish technical and economic feasibility. That is, again, part of giving perspective. Next one. Okay, we've got some samples in this seminar today. This is a device and it's ideal for indoor air quality. So we're going to proceed through a handful of these that include the lighting and the HVAC. This one in particular is really ideal, not just for the IAQ, but for the small to mid-size and pilot projects. And the reason it's small to mid-size is they're mounted on the wall versus in the ducts, which is a more systemic solution. So the core technology here is ultraviolet, that's UVC, that's the wavelength, and it's from light emitting diodes, the LEDs. Coverage area for these devices, typically 400 to about 1,000 square feet, and that's at typically an 8-foot ceiling. The reason there's a range is there's different model numbers that are sized based on the output of that irradiation from the LEDs. The size of these, 8 inches high, 24 wide across, and typically only about 4 inches deep. And the other one is a little boxier, 17, tall, 12 wide, and also about 4 deep. So these eliminate over 99% of the airborne contaminants. And we have on the next slide some testing information we'll share with you. The cost on what we're going to cover today is based on certain volumes and discounts. So instead of giving out numbers, we want to find out the level of interest for the samples, and then we'll circle right back to you with those price points. The highlights, in this case, an air purifier that destroys viruses and other pathogens that affect your air quality. So the optimal UVC wavelengths of the 265 nanometers is for that disinfection. No hazardous mercury or fragile glass. That's a differentiator from the ultraviolet tubes that have been used since the 1960s, given the advantage of this particular device with the LEDs. We still have, as an offering, the ultraviolet that comes in the tubes, but we thought for this seminar it'd be important to feature this particular LED device. Now, when it comes down to built-in surge suppressors and protection, that's a big advantage. It came up in a conversation with a courthouse and a jail. It's a prospective client of ours down in the South, because they were worried about power outages and how it might affect the equipment. In this case, there's also the zero ozone third-party certification, meaning the UL, that's Underwriters Laboratories, 867 and the UL 2998 standards. Warranty, 30,000 hours in 5 years. That's excellent. We've looked at so many devices over the last really 2 years, and I can tell you that's ahead of the curve there. It ships with cord and plug for the standard electrical outlets, and has the built-in holes on the back so that it can be easily mounted. And it comes with optional networking, controls, and monitoring, which is a huge advantage. Next slide. Thousands of these units have been installed. This is really the performance highlight. So as we go through each one of these few products we're going to feature today has the kind of the high level that I just described, but then the performance highlights. And it's been commercialized. In this case, it's the most recent of the products because of COVID. It was really launched last year. So the testing highlights. Olympia Lighting, and that's the manufacturer, received a virus reduction efficacy test report on its UVC linear LED strip testing. It's great because the testing was by an independent lab called Microbach. Microbach Laboratories, Inc. is the group that has the technology, and it found that this device provided over 99.9% reduction of the COVID-19 virus, SARS-CoV-2. Microbach conducted testing at a standard distance of 1 meter and exposed the virus cell culture plates, the basically Petri dishes, to Olympia's UBC device for 1 minute, 4 minutes, and then 8 minutes. In the testing, the 8-minute exposure resulted in the highest percentage of reduction of over 99.9%. And moreover, there was a virus reduction of 99.4% in just 1 minute, showing that Olympia's UBC device is highly effective. This particular wall unit tested by Intertech's microbiological lab to a 99.9% microbial reduction. Bonus. Okay, clean the air is the message here, and it's not as expensive as people think. It should be done. It should become a new standard, a new normal in a way, just like we have sprinkler systems, that prevent fires from spreading. The portable wall mount and the induct devices that we offer at the IAQ Technologies company are really a powerful tool to prevent another one of these pandemics from really spreading. Okay, next slide. Sample fixture. So let's look at the lighting. Lighting is clearly the low-hanging fruit of energy efficiency. And the next set of slides is really going to talk about saving energy, which is really saving money. Ideal for lighting optimization at any size projects. Harness cost-effective light-emitting diodes. So we're talking about multiple fixture types to address the lighting needs of a diverse range of facilities. Tubes that replace fluorescent tubes. Troffer fixtures, 2x2 as well as 2x4 that come in multiple form factors, architectural, volumetric, as well as flat, vapor tights, often in industrial facilities or like parking garages, even sometimes stairs, and then the stair and hall fixtures specifically designed for those uses, as well as strip fixtures, which are often in, like, say, mechanical rooms. There's more. Next slide. We also cover, and this goes back to, over 10 years of production, aisle lights, the narrow recessed fixtures, the narrow pendant fixtures that hang, the remote pendant. We call it remote because the driver is separated up in this ceiling and the cable comes down running the power to suspend it. In this case, the deep fin heatsink is what creates the structure. That's one of my personal favorites, that remote pendant. The high base, or even up to 1,000. So LEDs, I don't think I need to convince anyone this call are a good idea. And these are the kind of tools that can now cost effectively replace the old lights that have not yet been replaced in many buildings, or for those architects on the call for new construction to get them in the specs. Next slide. One of the particular reasons to spec an Independence product here is that it's made in the United States. It meets the Buy American Act, the BAA standards, with over 50% domestic components and what is called substantial transformation of materials here in the US. Over 50,000 of these units installed, unbelievably, almost negligible failure rate over the years. And I can tell you that since 2012, having been involved with really this company, the whole journey, it's an exciting proposition that now LEDs are so mainstream. I used to joke with my I had a 4 or 5-year-old when we started the business, and we'd go to the Home Depot and ask for the LED tubes, knowing that they didn't have any. I mean, the only LED when we got started was literally in a flashlight. So now that it's so common, it's really about the 10-year warranty and how we can be competitive in that space for the thermal management, which is that little drawing on the left. Those are the fins on the deep fin heatsink. And if you were to fold a piece of paper inside there's 9 inches of the surface area across that heatsink. We're talking about achieving excellent energy savings with that made in America quality. Here's a sample scenario. So 2x4 troffer with 4 fluorescent tubes at 32 watts each. Typically, they're about 1,680 to about 1,800 directional lumens. That's the output of light per tube in these fluorescent troffers, yielding what is 128 watts, 32 times 4, and the 1800 times 4 is 7200 lumens. Well, that's the goal, to match or exceed, the light output. Well, in this case, we can have, this is the R3 kit. It's 4 feet, they're tubes, but the strips inside are the printed circuit board with the diodes, has the external driver, and then it can replace 4 fluorescent tubes. So what that means is you're coming in the 54 watt level and 7,725 lumens. So it's less than half of the energy and equal or greater output. This is how it translates into dollars. So 74 watts, which is that almost 60% savings, right? 57.8. If we use the US average of about 11 cents per kilowatt hour, and an average office like, 6 or 7 a.m. to 6 or 7 p.m., like 12 hours per weekday, you end up over 52 weeks with 3,120 hours. Just to give you an order of magnitude, a full year is 8,760. So it's a little bit less than half of the total hours, even closer to kind of a third. Well, that energy savings, 74 watts per fixture, divided by the 1,000 to turn watts into kW, times the hours, is going to be, this $230.88. And that's based on using that 11 cents per kilowatt hour. I cannot tell you that it drives me crazy that more facilities haven't just all switched over to LEDs, whether it was dropping off a sports coat at the dry cleaner and seeing the old fluorescent tubes. I'm not sure what the exact data is, but I think we're between 15 and 20% adoption for existing construction. Most new construction has LEDs spec'd in, but it's certainly time to change the lights. Next slide. Okay, we're going to close the technology discussion here with this sample device, which is an HVAC optimization tool. So we've covered indoor air quality, we covered the low-hanging fruit of lighting. Now it's about the energy. Also ideal for small to mid-size and even some pilot projects. So the core technology here is an adaptive climate controller, ACC, for fan speed. Coverage area, variable to the air handler size in the cubic feet per minute. It's only just a little bit less than 5 inches, across by 4, and then 2.75, almost 3 inches high. And it weighs less than a pound. So the highlights are this potential savings of 20 to 40%, depending on the equipment and the operating conditions and the HVAC air handler. Now, this is proven smart control technology that has been installed in facilities ranging from schools to hotels, with over 40,000 units in operation. Key features, this is important, the Wi-Fi enabled, which is an option. It's cost effective, highly efficient, quiet and clean control of airflow. The applicable, for single phase, induction, electrical blower motors at either 120 or 240 volts alternating current wiring. So really almost a universally appealing tool, given that it can go in so many different places. Next slide. So here's the performance on it. You're talking about a story of over 40,000 of these installed devices with less than this 0.025% failure rate. And this is not a newcomer to the space, right? Within this next year, it'll be 13 years of operating these different devices in these facilities. And that's pretty exciting, given that it's been kind of a hidden secret in a way. I can tell you that from the energy savings highlights, this Demand Responders ACC series achieves the excellent energy savings, and it comes with this Made in America option, especially for the government contracting. Sample scenario could be a 5-ton air handling unit with an average of, say, 400 cubic feet per minute. That's the CFM per ton for a total of about 2,000 CFM. Now, the uses would be the PTACs, the RTUs, right on the fan coil, or the AHU with that 120 to 240 volt alternating current, and that induction permanent split capacitor, that PSC, and the indoor fan motor. Now, the ACC solution is one unit with the Wi-Fi to show real-time energy savings, and it's awesome for pilot projects. So again, referencing an average like we did with the US of about 11 cents per kilowatt hour, and an average runtime of about 12 hours per weekday that gets you up to that 3,120 annual hours. Here's an order of magnitude on the savings. ACC saves on average is 20 to even 44%. So that includes the gas and the electric, by the way. Consider that 40% is not an unusual number in terms of the percentage of HVAC for your utility bill. Well, that means that the total monthly bill in the case of something like $1,000 at 40% would be a $400 savings, and that's real money. And that estimated savings per month could be between $80 and $176. And that's based on the model conditions. To give you a sense of why this is so effective, it's pretty simple science. What we're talking about is the speed of the fan. In your home, you might turn your fan on the HVAC on the thermostat to auto. Well, that means it's going to be running when the coils are either cold or hot, and it warrants blowing air across them. It's not the same when it comes to commercial because the order of magnitude is so much higher than your home. We adjust with this device the level of speed of the fan. So when the coils are warmer, the fan will run faster. You're taking advantage of that warmer coil. Same thing when it's colder. So this is about modulating the speed of the fan. This is not rocket science. This is pretty simple. The device comes and it's in that lower photograph. The coiled black cable has a heat sensor. It's a temperature sensor. And it is sending a signal to this device that is incredibly cost effective because it is not doing what the much more extensive and complicated building management systems do, which is try and use algorithms and all those other things to optimize energy. This is blocking and tackling. Use the electricity when you need it most to run the fan faster, to move that air over the coils, to get to the desired temperature of the interior spaces. Next slide. Beyond these devices we covered today, comprehensive solutions are available. We'd love to discuss your equipment and the needs. Could be the equipment of your clients if you're an architect or an HVAC company, or if you've joined us today because you're interested in connecting the dots between what we offer and maybe some of the contacts that you have in the industry as a lead provider on the expanding sales force. Great. This is about taking what is available and aligning it to what makes the most sense for that building. We're happy to prepare, effective energy and air quality assessments. We bear, in many of the cases, the burden of the time and the effort from the data collected to prepare those preliminary assessments and really give customers a roadmap on what their potential is for cleaner and improved indoor air, as well as the energy efficiency. Next slide. Thank you. The CleanTechSolutions from IAQ Technologies, LLC, and the Energy Intelligence Center for Safe and Efficient Buildings. Jeffrey's been our moderator today, and his contact information is there. He will follow up by sending out this deck as a PDF and also take the recording. And I think trim maybe the front end off when we were just waiting for the attendees. But we're happy to open it up to Q&A, and I'll do my best to answer any of the questions that you may have, or we can circle back with those answers, through the email. What do you have, Jeffrey, for us on the Q&A? Did anything come in?
We have the measuring of efficacy for the UVC solution.
Okay, so I can speak to this where the files that have the rigorous testing from the third parties are going to be made available to the attendees. So I think that, Jeffrey, you can circle back with John Conklin and decide whether to post it as it was
Sure.
posted on the Purge Virus website for all of you listening in. Purge Virus was the brand that we expanded to include IAQ Technologies, because beyond COVID, as we start to hopefully peel away from this, the mold remediation, the things that can be done with ultraviolet are also important as a new standard for indoor air quality. COVID woke us up, and now it's time to look at really a systemic change in how we think of building indoor air because of sick building syndrome. I think there's some number, it's close to $20 billion a year of healthcare costs that are associated with sick building syndrome, the glue in the carpet, the new smell of sneakers that walks into buildings, all those toxins from cleaning fluids. So I can tell you from the testing on the efficacy that there's very rigorous protocols by third parties, and it has to do with the irradiation level, so that when you have a component of the dosage, it's time, intensity, and distance. So if you imagine in that device that's on the wall, you're drawing the air in. Well, you have to have enough juice, meaning the electricity to charge those LEDs, or in the case of a duct, to power the fluorescent equivalent, which is the basically a fluorescent tube without the phosphor to get that UV light, the UVC. So you need enough time for that dosage and the intensity of it to reach that molecular organism, that acellular molecular COVID, and basically prevent it from replicating. If you think of those spike proteins, when you see the image of the COVID, it's really about irradiating at that level its ability to replicate. You're disrupting the RNA and the DNA within that cell. And I'll tell you, it's been proven to work. We would not be representing it if there wasn't the verification from the third-party tests. And we can follow up with the group, either sending out a link where those test reports, for the wall mount, Jeffrey, and the other devices reside, perhaps on a page within the IAQ Tech website. Okay, is there another question?
The power consumption, especially as compared to Signify's GUV tube-based devices.
Okay, I'm not immediately familiar with that one. I have to pull it, but I think that's one of these questions that we'll follow up on. And I'd love that we can do, as we have for some of our clients, side-by-side analysis. So the power consumption compared to the, what is basically the micromoles and the irradiation level is a very fair ask. I know we've done some of those comparisons in the past, and we've also compared them to bipolar ionization in terms of the electricity draw. So the draw, Jeffrey, as a task is going to be the ultraviolet with the tubes compared to the ultraviolet with the LEDs. And the third piece would be to the bipolar ionization. In general, I can tell you that cleaning the air has a very low energy cost at light bulb level in many cases. And that if we put the devices in the ducts in the correct spot, it's often about 18 inches from the fan coil, we can irradiate the mold and the mildew and those other microorganisms that exist that create fuel efficiency waste in terms of the energy waste. So there is a point where it will actually save money and use, if placed correctly, less energy than it is consuming in the ductwork. That's not necessarily the case for the wall mount and the portable devices, because they're not doing as much of the cleaning, up at the air handler for the fan coil. But we can do that matchmaking assignment, Jeffrey. It's a great question. That there may be already pieces of that study that can be also posted online.
And next, can the ACC be controlled by CO2 levels identified from a BMS?
Interesting. I think that's a follow-up question for the guys at Demand Responder with Daniel, because we've only seen in the type of questions and in the implementation that the temperature is what is controlling it. But I don't know that if there would need to be a different sensor, to be able to facilitate that. So if it is controlling the fan speed based on the sensor that is the temperature sensor, I'm not going to definitively say either way that it can or it can't. But I think that's an interesting question to get back to as a follow-up. It hasn't come up, but it could be an interesting additional sales point, because maybe there's an add-on sensor that can still use the intelligence of the device to basically make that air handling unit smarter.
Very good. At this point, there don't seem to be any more questions, but everybody, please know, should anything come up, feel free. You know how to contact me, and we will get back to you straight away with any and all information possible.
And let me just say a parting word that I would really encourage those attending to reach out to Jeffrey, because